I did realize, actually, I spoke about the alien thing as being one of the big questions. It's actually not the biggest question. For me personally, the two bigger questions, setting aside dark matter for now, is the nature of consciousness, because that is just fundamentally blows my mind. I don't know enough about it to speak about it, but it just, wow. And the other is what came before the Big Bang. Now, is that even a physical question? If time arose in the event of the Big Bang, then there really isn't a question to say what came before. It's like what's north of the North Pole, right? You've reached the point. So that to me is a truly stunning question. The fact that we can even measure the age of our universe, 13.6 billion years, with an error bar that's better than I can estimate your age. That is, how is that not something we have tattooed or something? That should be a constant reminder of how audacious we are as a species.
We should be walking down the street going like this all day, every day.
That's pretty good.
Yeah, it's not bad. It's very impressive. I think the problem with what's before the Big Bang is because the power of our human brains combined and all the greats before us and, standing on the shoulders of giants scientifically and all that stuff, there's obviously a process that, I believe, there's obviously a process that our brains cannot fathom. Because at the moment, I mean, this is probably been discussed in your areas and people that, that you kick around with, but if you think of time as a linear thing, and here's where it started at the Big Bang, well, what was before that?
Yep.
Okay, so you can just keep doing that forever. That's an unanswerable question, because you go, oh, well, what happened with the pinhead is there's a process that went on for blah, 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 and what started that process? You get caught in that swings and roundabouts. But the thing is, there must be a process that our brains cannot fathom. So I don't know if it's what happened before the Big Bang, because maybe time started at the Big Bang, like you say, but it might be, what process do we live under? How does this work? Is time a cyclical thing, and where we're getting back to the start of the Big Bang? And we don't understand how that would work, but there's obviously something that we don't grasp right now, I feel like. And I feel like it's not a when does it start thing, it's how does it work thing. You know what I mean?
Yeah, well, we would hope that a fundamental description of nature, and this is described as a theory of everything, which eluded Einstein, that would have the answer, right? So that's the process we live under. Each stage of scientific discovery has allowed us a greater insight into the universe, and has allowed us to ask deeper questions and even more challenging questions, right? Before we realized that general relativity was the correct answer, we could talk about an eternal universe, which avoided then the challenge of, well, what came before this? It's always been like this. We know from general relativity that it's not possible to have an eternal universe, or at least not one that remains visibly the same. It changes. Stars inexorably pull one another together. We now have dark energy, which is apparently inflating the universe apart. It's going to look different 10 billion years from now than it did today, and certainly 10 billion years ago. So we can see that there's a change. Well, it's obviously human instinct. And we did it as, 2-year-old, 3-year-olds with a why. And we asked that question then, of well, what did it look like at the start? And we can get to, depending on your flavor of physics, we have an image, quite literally an image of the universe as it was 380,000 years after the Big Bang. That's the cosmic microwave background. For maybe the older listeners, when they had their old analog TVs and the aerial was there and you would lose the channel and it would all be a static hiss. About, 1 in 100 pixels on your screen was you picking up that afterglow of the Big Bang. So you were performing cosmologies, you're trying to tune into, I'm guessing like, hey, it's Saturday or something in those days. So that was, that's not bad. And then we can go to nucleosynthesis, so the formation of the elements themselves, about 3 minutes after the Big Bang, when the universe was so hot and dense as to be the similar conditions to the center of our sun, right, where new elements are forged. And we look around and we see the abundances match what we would predict. So we can see, and air quotes, what the universe was like. It was like the center of the sun. And then maybe you push the start time back to the energies that we explore at the Large Hadron Collider, the atom smasher in CERN, in Geneva. And that's now getting us to, a billionth of a second after the Big Bang. To go much earlier than that takes even higher, you're talking about a universe of such extraordinary densities, temperatures, energies, that we can't recreate that on Earth. Now, we have a theory called inflation that, I don't particularly want to get into, but there's a sense of how the universe could have arisen as we see it today. And that's now going to the Planck time. That's 10 to the minus 35 seconds. I mean, that is just an extraordinarily small window of time. There is an imprint potentially detectable from that on the universe, and we can call that primordial gravitational waves. About 5 years ago, we thought we detected them, and we have not. We realized it was essentially dirt on the camera lens. It was dust in the Milky Way, but it was effectively on the camera lens.
Was Ralph here last night? Ralph said he cleaned last night.
Yeah. So that was a bit embarrassing. So that was, but then it doesn't answer the question, because of course you can always say, well, what came before that, right? And at some level, Planck time is that's where that question breaks down. If you get to that point, you're with your 2-year-old, 3-year-old kid, then one, they're a genius because they've got to that point. Yeah. But you have to stop. There's just a fundamental point of it breaking down. And even the theory of everything that eluded Einstein, that we talk about the quantization, or the quantum meets GR, so quantized gravity. The description of the small meets the description of the very large in general relativity. That would end. That would have to have as its most smallest quantized step would be the Planck, because to go smaller than that has no meaning. That's what we suspect, but will we even ever reach that? Who knows? And it doesn't really. It's not clear that would still answer this question of our origin, which is what drives, I think, a lot of science, or a lot of scientists, is the same thing that I think drives a lot of us, and certainly would drive those amongst us with, a sense of spirituality of, what is my place here? What was my origin?